Cool. All right. Well, I'll give you a sense of, kind of the various things that weights and biases can do with YOLO and sort of generally how I think about MLOps, right? So, as and I've been doing machine learning for a long time. It's really exciting to see how it affects different industries, right? In transportation, we see, autonomous cars, long haul trucks, even self-driving tractors. We actually work with John Deere to automate agriculture, like sprayers spraying in fields. We work with Microsoft and many others to assist in developing different kinds of medicines and different kinds of predictions on outcomes for patients, which can be really important for folks. We also work with the Royal Bank of Canada to help with order execution and demand forecasting and many other things, right? So it's really cool to see all these things actually like working in the machine learning field. But you do see so many machine learning projects fail. I think everybody's got a story around this, and now things are high profile enough that they actually fail very publicly sometimes, right? Gartner claims that 85% of machine learning projects actually fail to live up to their goals, right? And so you ask yourself, like, why does that happen? I think the majority of engineering projects don't typically fail. And so I guess I really believe, and this is why I started Weights and Biases, that it's a real lack of best practices in machine learning, kind of consistent best practices like we have in engineering, and high quality tooling, right? And I think like what you see often, right, is like you would never write code, for example, without checking into some kind of version control. But people build models all the time that they don't save in a systematic way. And I think like, models are becoming, as important IP as code. And yet like companies aren't really like treating often those models in that same way. And actually, machine learning adds a whole new slew of challenges, right? I mean, there was that famous paper, machine learning, the high interest credit card debt of, of technical debt. I think that's really true, right? There's sort of new dependencies that we're not used to. And so lots and lots of bad things can happen if you don't, build out your machine learning models in an organized way. So, what does an ideal workflow look like? I mean, these were the things that we were thinking about. I hope this resonates with you, but these are things that I really want. And different companies would sort of describe these in different ways. But like, I think auditability, whether it's, like a regulatory body that's saying, it must be auditable, or you just want to have like a sane practice where if something goes wrong, you can trace it back to where the problem was. I think auditability is really crucial. People talk about the reproducibility crisis in machine learning, and I think it really is a big deal. And there's many different levels of reproducibility. And I guess all these things really matter. One more that I'll call out is I think collaborative workflows are even more important in machine learning than engineering. I think machine learning and data science has to touch many, many different parts of an organization. And so, making sure that like collaboration is possible is really crucial to what, how I think of a good workflow. And so like, what does weights and biases do, right? So, we sort of sit, I guess, at the sort of interface part of a stack, right? So there's sort of like the place where you actually run your models, right? And that might be, Amazon, Google Cloud. It might be that, you run your own NVIDIA hardware, something more exotic. And then on top of that, you have this sort of like, frameworks and toolkits. And this is, I mean, I would put, kind of PyTorch in that category. I'd also put like YOLOv5 in that category. I mean, YOLO is obviously really, really excellent at helping people, quickly get up to speed training vision models. And that's why we've integrated with it, right? We integrate with, the stuff that we see people really use, and YOLOv5 is one of the most popular frameworks out there. But then what we do on top of that is kind of enable the workflow, right? So we make it easy to visualize what's going on in the training and also keep track of what's going on, have a record of everything that happened, and easily kind of share that with your colleague. And then, actually keep track of what models are going live into production. And, it's really important that this actually fits into your workflow, right? So I'll just say, we've integrated our stuff into every framework. We've, instrumented, actually now over 10,000 repos. These slides are a little bit old, right? And this is because we want to work with everything out there that you might be using. And the way it works, just to be clear, is when you start a weights and biases, when you run YOLO, for example, right? If you turn on weights and biases, you'll create an adjacent process on your local machine, whether it's where the training's happening or production. And that's going to be streaming data to a central weights and biases server. And now the free version, it lives in the weights and biases cloud at W&B.ai. You can also download a free version that would run on your laptop or somewhere, or we can actually deploy weights and biases into your cloud infrastructure. So I'm just going to kind of go briefly through, like, kind of 4 of the things that we offer that I thought might be particularly relevant to YOLO users. So let's start with experiment tracking, right? So, experiment tracking, the idea here is that you, when you train stuff, it's hard to see what's going on, right? So this is like a real visualization of a real YOLO workflow. So, when you turn on weights and biases, suddenly you can see the curves of your training. You can see if it's getting better, getting worse. You can see how it's doing across lots of different metrics, right? Like, you're never optimizing just one metric. You want to see how they're all doing. And you can also see images of exactly what your model is doing. There's no substitute for actually looking at a specific example. And this is what you get out of the box. But we have a really rich framework for logging anything simply, right? So, you can log molecules, you can log videos, 3D objects with bounding boxes, kind of everything you want. And we're going to visualize it nicely in weights and biases. This can also really help you preparing and analyzing your data, right? So you can basically save every step of everything that happens and kind of slice and dice it in lots of different ways. I mean, everybody's got a slightly different workflow, and we want to support the way that you're working today. Over time, what's going to happen is you're going to have typically at scale, you're going to have models that output data that feed into other models, right? And you're really going to want to see that. You're going to want to know at every step of my, pipeline, like, how did I prepare my data? Maybe you have a model where the output then becomes input to the next model. And then you can also kind of compare models, interactively. So seeing, like, hey, I tweaked something, I lowered the learning rate. What did that do quantitatively and qualitatively? Like, what are the strengths and weaknesses? And then as you figure this out, you're going to want to collaborate on, best practices and insights. So you can build these reports, right, and pass them between each other. I think one of the things that made me want to start weights and biases was actually, trying to reproduce work in papers, right? And, papers will be this like 7-page document where there'll be this little table of, like, 10 of the things that the researcher tried, but they tried hundreds of other things, and they're leaving out, like, really important details. With weights and biases, when you're logging everything there, you can basically create a report, and then that's going to actually allow, someone to see the insight that you got, and that someone could be your future self, right? Also, probably it's like your colleagues coming in, and they see what the model did, but then, there's also like this trail of going back and digging into more detail, right? So if you think maybe there was a bug in the code that influenced the result, you can go look at exactly what happened on each model trained. And so these end up being what reports look like. If you go to W&B.ai/fully connected, you can see lots of examples of reports that are community built. And you can see here, that it ends up often looking like kind of like a pull request, but for, machine learning, where, every time you make some new step in your model evolution, even if that step is a dead end, you kind of record it forever for posterity. And so, what this becomes is a system of record for all your work streams, right? So, we work with teams of hundreds of ML engineers, and we also, work with 1-person teams and 2-person teams too. But at the really big teams, you want to have a track record of everything that you build. And so, Toyota uses this way, where every model trained goes through us. OpenAI uses this in this way. Lots of companies eventually, kind of end up standardizing on weights and biases because they want to have this system of record. And so, this is maybe the most important slide in this deck. I'd just really love for you to try it. It's totally free for academics. It's totally free for individual use. And you can get started with YOLOv5 with a really simple setup here. I mean, YOLO's done a really nice job of making this super easy. For those of you in the chat who haven't tried it yet, this is really easy to add, and you can see for yourself if this is powerful. And if you want to ignore the rest of my talk and just set this up, I wouldn't mind that at all. I think that would be an awesome thing for you to do. For example, here's how to debug with bounding boxes, right? You just add a command line flag, say bbox interval 1, and now you can actually see the bounding boxes that YOLO is predicting, and you can use that to debug your YOLO models. So this is really what we're known for, but I want to talk about a few more few of the stuff that's kind of come out in the last year from weights and biases that have been really popular. One thing is model registry. This is a real pain point for lots of our customers where people have trouble, tracing the model lineage. They're not kind of tracking the exact same metrics and the things that go into production. There's always a question of exactly when a model went into production. So we wanted to help with the evaluation cycle that we see people really using out in the world, right? And it's like this loop where you're basically training a model and evaluating it, deploying it, and then it doesn't stop there, right? I feel like workflows tend to go like left to right, but in the real world, people are constantly trying to iteratively improve their model and keep track of what's going on. So, we think that the real pillars here are versioning, lineage, and lifecycle, and that's what we help with, right? So you use the same exact training code that the same YOLO code that I showed you on the earlier slide, but now you're basically marking models as registered models, which lets you do things like versioning, right? So you automatically get a track of every single model that gets pushed into production. And you can use a single log artifact, which will keep track of all the data that fed into that particular model. And so it ends up looking like this on your team page. You can see all the latest models that somebody's pushed live. You can use the same tracking to go dig into how that model was trained. But you can also see kind of details on what was the input and output data of the model, when was it pushed live into production. All right, so the next thing that's important is lineage, right? And so that's exactly, you want to know exactly what's the data set the model is trained on. For some of our customers, they want to know that some particular piece of PII data or like corrupted data like didn't get into a model in production. For other people, they want to know when I push this other model into production, what was exactly the data that it was trained on, just to compare it with the next model. Maybe wondering, why did the model get better in production or worse with the new version? And so you can create these charts with our model registry. This is automatically being tracked in the background as you trained your model. Now, the final part is lifecycle, right? And so that's like basically keeping track of when models go into production and out of production. We made this super, super easy, right? Because we really want to add the minimum possible overhead to your life so that everyone in your company will actually use this. And what you get here is basically like a big list of all your models and this lineage on how they were built and how they were trained. You can also build kind of cool graphs over time where you can sort of see your team's progress. For example, here is the accuracy over time and the different models that were pushed into production. But you can slice and dice this in a million different ways. The lineage here, so this is artifacts you can actually do outside of a model registry, and it's very, very simple, right? You basically add W&B inits at each pipeline stage. You add log artifact when somebody's using the output of a model, or when a model is like creating something like a data set or a model, and then you add use artifact, track the inputs to models, right? So now you've actually connected your data prep, your model training code, and your evaluation code. These can all run on separate machines, different places in the world. And now you actually have perfectly tracked lineage forever with just this very, very simple modification. You can capture changes. So this is going to automatically version the different inputs and outputs. Like, you may actually run the same data prep code that doesn't modify most of the data. And Artifacts is going to be smart about only tracking the diff on these files. Or, you may, be producing the same model for a while that you used to evaluate, and then the model changes. This is all going to be, super smart and captured here. Again, the main thing that people are using here is data sets and models. All right, I want to talk about another thing that could be super useful for you, which is jobs and automation, right? So kind of as you move from experiments to sort of like dialed in workflows, you may want to use something called weights and biases launch, right? And so this does two things. It connects all the work you're doing back into your infrastructure and allows you to trigger automated jobs. So an automated job might be, every time a model gets, promoted to a candidate for production, you want to run a set of evaluations against it. And then when it gets, pushed into production, you want to run more automated tests against it. And you can really set this up any way that you want to. I'll give you kind of a screenshot of how this looks, right? So there's, you have your project table where your models are showing up, your dashboard where you're watching them train, your AWS instances could be, your own servers, it could be Google Cloud or whatever, and then your launch terminal. And you can see here, actually, here we're queuing up a job, we're picking the Kubernetes resource, and we're sending it into a queue. The job now gets picked up in AWS from the queue. You can see the new pod spin up automatically in the AWS EKS service. And you can actually see the live running metrics as the job runs. You can then automatically, or here's another example of thing you could do with this, which is automatically evaluate a new registered model. In a registered model, we have a single, we currently have a single version in production. So we can create a new action, right? So when something goes into production, we want something to happen here. In the model evaluation job, we can use the new model in the registry. And now when you add a new model to the registry, and this could either be through the UI or it could be through our SDK, the new challenger model actually triggers an evaluation run. So this could be like a long-running job, runs in a different cluster somewhere else. When this is all set up, you can actually be automatically triggering jobs either from the UI or from something that happens through a script or through your terminal or through your Colab. And I think the best way to experience weights and biases, I actually don't do a lot of talks like this because we really want our software to speak for itself. We'd really love for you to try it. If you go to w&b.me/YOLOv5, we'll give you YOLO specific instructions on how to set it up, but it really is super simple. It's basically installing a library and adding w&b.init to a Python script, and you'll get value there right away. And I guess if you want to see how other people are using weights and biases, you can go to w&b.ai/fully connected. And that is my talk. I'm hoping you all have some questions.